This is generators and power walk. We're going to start with how a generator works, motion into electricity. With the hand generator, motion, energy from your hand, which gets translated through the handle, through the gears. Silver cylinder in there, that's where all the magic happens. That's where a coil of wire is rotated through a magnetic field. When you move a closed loop of wire through a magnetic field, current is induced in the wire. Okay, because that magnetic field exerts magnetic forces on the electrons in the wiring, causing them to flow. This cardboard core solenoid with galvanometer is like it's a generator, really. Use a magnetic field, pass the magnetic field through the wire or the wire through the field. It doesn't matter. The magnetic force of the magnet exerts magnetic force on the electrons in the wire, causing them to flow, and then you have current, you have electricity. Click on that link, and it should show you another demonstration of what I just did. So basically, you need three essentials to get electricity. Then you need a wire, a closed loop of wire, a magnetic field, and motion. So you need a closed loop of wire and a magnetic field, and you need to move those through each other in some way. So all that makes all of the different types of power plants different is where that motion energy comes from. What provides the motion energy? That's as far as we've gotten. I mean, in our civilization, aside from photovoltaics or solar cells, it's just like, well, here's something else. We can make water move the wire through the field. We can make wind just move the wire through the field. Most cases, we could use steam, which is, still water, to move the wire through the field. How can we make steam? We could burn coal, enrich uranium. Well, why wouldn't we burn wood? It's not very efficient. Wood has not nearly as much chemical potential energy as coal does, for example. And it's still not burning all that cleanly. Natural gas can be burned to provide heat, which then boils water, provides steam, which then moves the wire through the field. I'll show you. All right, we're starting with coal power plant. So click on this link. You need to boil water so that then you shoot that boiled water through piping, highly pressurized water through piping, and it spins the blades of the generator turbine. Okay, not turbine. Trust me, I took actually like an engineering class that was devoted to turbines, not the headdress, but what people call turbines. And the dude, the professor, he's not like some young guy. He's like some legitimate older gentleman. And he said that's what you call him. You just use steam to push the blades of the turbine, which then moves the coil of wire through the magnetic field. All right, so you got motion energy converted into electrical energy by the generator. Next is nuclear. All the same thing. It's pretty much the same thing as coal powered, which is hard to believe. But it's except instead of burning coal to get the heat, which is then used to boil the water, generate steam, which moves the wire through the field, they used enriched uranium. Through set conditions, they get the uranium to release neutrons. Okay, this is essentially nuclear fission, the splitting of a nucleus in a controlled manner. When you do that, releases all this energy in the form of heat, and you control that amount of heat that's released, because if you just let it go crazy, it will cause some serious problems. If you were to visit one, they're like in a giant swimming pool, it looks like. And so they use that fluid to control the amount of heat that's released. So anyway, you get the heat released from the uranium, and that heat is used to boil water. Heats up water, superheated water travels through this piping, generates steam. Steam shoots through this piping, is blasted out of this, and then it forces the blades of the turbine to rotate, and then that moves the coils of wire through the magnetic field, and you get your electricity generation. That steam here, check us out. So that steam goes in here. It does that, forces the blades of the turbine, and then it condenses in this condenser, meaning it cools down and goes back into its liquid form. It does that because this piping, here's cool water being piped through. That cool water steals the heat from that vapor and condenses the water, cools it down, and then that water collects here and gets pumped back and gets reheated again. So this is like a little cycle here. And this water, which steals the heat from that incoming steam, goes into this tower. And when I was younger, I thought that this tower was like where all the nuclear action happened. Meanwhile, and there's looked like smoke coming out of the top of it. Meanwhile, this is the most innocuous thing. It's just a cooling tower. All it is just cooling this hot water down. And so what you're seeing come out of the top of that is just steam. All right, hydroelectric. What provides the motion energy to turn the blades of the generator turbine to move the wire through the magnetic field? Just water. Water in its liquid form. It's not heated to be converted into steam. It just uses essentially gravity, build up this water, build it up. It's going to want to level itself out essentially because of gravity. And so as soon as you provide like an outlet for it, it'll come shooting down. This is just for scale. I don't know if anybody's ever been to a hydroelectric power plant, a legitimate one, but they are massive. Water comes in, hits these blades of the turbine, causes the whole shaft to rotate. This moves the wire through the magnetic field and you get your electricity generation. Wind generators are just like hydroelectric, except instead of water spinning the blades of the generator turbine, you have wind. Wind causes these to rotate the blades, which then rotates the shaft by gearing, moves the wire through the magnetic field, and you get your electricity generation. It's quite literally like this, except instead of having this handle here rotating that way, you just put some blades on here and get wind to move it. Photovoltaics, solar panels. This is the one that's different from all the others. This doesn't use water in any form. In fact, it doesn't use motion like the others do. It's just like a direct conversion of sunlight into flowing current. Solar panel absorb photons of light, which are like little packets of energy. Absorb that, and then the electrons get all excited, and they want to go, they want to move, they want to flow. And through proper construction, they're channeled they're captured and channeled and allowed to flow in a controlled manner. That's it.